So here we want to integrate e to the x times sine of 3x dx. Now when you're choosing your u and your dv, in this case it works either way. So you can let u equal e to the x, you can let u equal sine of 3x. Turns out this is going to work out just fine either way. If you're following the LIATE process for choosing u, then trig function would come before exponential. So I guess I'll take that approach because I know that a lot of students like to use it. The other upside to letting u equal sine of 3x is then you can deal with this extra multiple, the 3, in your derivatives as opposed to the antiderivatives. And maybe that's easier to keep track of. That would be, someone's personal preference, but maybe that's another reason. But for the record, you can solve this problem using either u equals sine of 3x or u equals e to the x. Sometimes it actually doesn't matter which one you choose for your u. Okay, but so I'll take this approach. So u is sine of 3x, which means du, if we'd have to differentiate using the chain rule. The derivative of sine is cosine. Leave the inside alone, times the derivative of the inside. So times 3, and then dx here. That leaves, for dv, we have, so this is u, e to the x dx. So dv is e to the x dx. Antiderivative of e to the x is e to the x. So that part's straightforward enough. Now, we apply that formula with integration by parts. So, oops, I didn't label this. This is dv. So this is equal to u times v, which I'm going to write the e to the x in front. So here's our u times v, minus the integral of v times du. So this is our integral of v du right here. Now before we go further, we should clean this up. So I would move the 3 outside of that integral. And now we're looking at the integral of e to the x times cosine of 3x, which looks a lot like what we started with. And so I can understand if you feel like, well, I'm not making any progress here. But it turns out if you stay the course with this, this is going to lead to a solution. So for now, it's just a matter of just trust me on it. So in order to integrate this, we're going to need to apply integration by parts again. So within that integration problem, I need to tell you something about this. So we got to choose a u and a dv. I told you in the beginning it doesn't matter which one you call u, actually. It's going to work either way. At this point, though, it is important that you stick with the same setup you used in phase 1 here. So since we let u equal sine of 3x, this go around we should let u equal cosine of 3x. I can tell you from experience that if you switch it up, if you let u equal e to the x this time, what you end up with is an expression that just collapses on itself. Everything just cancels itself out. And you end up with this starting integral equals itself. And then everything else cancels itself out. So to avoid that, just when you apply integration by parts more than once, you should stick with the same general setup. So if u is the trig function this time, continue to let u equal the trig function second go around. To differentiate this, we have to use the chain rule again. Derivative of cosine is negative sine. Leave the inside alone, times the derivative of the inside. So then that leaves, here, if this is u, the e to the x dx, that's going to be our dv. So dv is e to the x dx. Antiderivative of e to the x is e to the x. And so for this integral that I boxed in green here, we will have u, I'm just thinking about what color scheme I want. I'm going to just write this in black. U times v, so again, I'm going to put the e to the x in front, cosine of 3x, minus the integral of v times du, negative 3 sine of 3x dx. Now that's just for this integral that I drew the green box around. So this is equal to all of this. And what's outside here just stays the same. So this is e to the x sine of 3x minus 3. You have this coefficient of 3 times all of that. All of this. So this is e to the x sine of 3x minus 3 e to the x cosine of 3x. And then we got to deal with these coefficients. So, and there's kind of a lot of coefficients to deal with. So coefficient on this last one, we've got negative 3, which we're distributing. So first of all, the negative 3 times the negative here would leave us with positive 3. But then you've also got this negative 3 here. I guess, how about I do this? So negative 3 times the negative 1 here. So this will be plus 3 times, we'll also pull out this negative 3 here. So I've got times a negative 3 from in here, integral of e to the x sine of 3x. So I know it's kind of a terrible mess, but we've got a negative 3 times a negative here will be positive 3 times this negative 3, which I'm pulling out. That's this negative 3 here. Okay, so let me write what we've learned overall. Here's the original integral. So overall, actually I'm going to write it up at the top here. What we know now is that the integral of e to the x times sine of 3x is equal to, all right, so we've got this. I'm going to copy from this step down here. So e to the x sine of 3x minus 3 e to the x cosine of 3x minus 9 times integral of e to the x sine of 3x. And I almost made it, just don't have room for the dx there. Sorry, I know it's a bit small. Okay, but notice we came back to the original integral. So we applied integration by parts twice, and we ended up circling back to the original integral, which is not as dire a situation as it might seem, because now we can actually solve for the original integral. This is what we're really after, right? We want to know integral of e to the x sine of 3x dx equals what? That's the overall question here. So what we can do, and I guess let me write this down. So our goal, remember the original question was integral of e to the x sine of 3x dx equals blank. That's what we're trying to solve. We can solve this equation for the integral of e to the x sine of 3x as if we were solving for an x. Suppose this was x equals all of this stuff minus 9x. What you would do then is you would add 9x to both sides. So in this case, we're going to add 9 times this original integral. Add that to both sides of this equation. So over here, think of this original integral as having coefficient 1 plus 9 times that integral. So we end up with 10 times the integral of e to the x sine of 3x equals this. E to the x sine of 3x minus 3 e to the x cosine of 3x. plus c if we want to. We can add the plus c later. So now, if we divide both sides by 10, then we've done it. We've got our final answer. Tack on the plus c. There's your final answer. Which, if I want, we could factor out, there's a common factor of e to the x in the numerator, and then over 10 times sine of 3x minus 3, because we didn't factor out the 3, cosine of 3x plus c. And there's your final answer. So, and it's going to be strictly integrals of this form. It's kind of a giveaway when we have these problems that are going to circle back to the original integral. When that happens, what you should do is move the original integral, collect those terms all on one side, and then just divide by the coefficient.